This is lesson 71, working with natural logs. Natural logs are logs with base of e. I already explained that before, but just as a review. So this is a common log. We assume there's a base of 10. When we see the button that's on the calculator, or we see this on this figure, natural log, means a log with base of e. And I won't go into the specifics of what e is, but e is called Euler's number. And it's a number that's equal to about 2.718, but it's an irrational number, so it goes on forever. And we use Euler's number in a lot of applications in regards to nature. We use it for sound waves and also for certain patterns in nature. So, but we're not going into specifics there. We're just learning how to deal with it when we, at a basic level, when we use it to solve logarithmic expressions, equations. Here are the steps for today. And I'm going to show you how to do numbers 1 and 2, and then we'll do a few of them together. So here we go, numbers 1 and 2. So the first thing I'm noticing on number 1 is I look at the directions, it says solve, right? So whenever it says solve, I need to ask myself, what am I solving for? So in this first one, I have an equal sign. We have one term minus another term is equal to a third term. We know that there's a 2, so I know that I'm not going to be erasing any natural logs. So we're going to use the same concepts as before from common logs. Okay, so I want to condense these two together, so we have natural log of x over 9 is equal to 2. That's the first step. Okay, so I just condensed that because I know that there's a minus sign here. Two natural logs have the same base. Now I'm going to convert this into a exponential equation. I know that natural log is the same thing as saying log of base e. You don't have to write this on your work when you do this on your homework, but when you see natural log, we're assuming log base e, so we're going to rewrite this as e squared is equal to x over 9. Okay. Now we're going to solve for x. X is over here and it's being divided by 9, so I'm going to multiply both sides by 9. So x is equal to 9 times e squared. Okay. So I got my final expression written out, so I could do one fell swoop on the calculator. But when I work on my calculator, I want to make sure that I'm using PEMDAS to solve for it. I don't want to just start writing 9. Okay, so I'll ask myself, are there any parentheses? No. Any exponents? Yes. So pulling out my calculator, I'm going to clear out my buttons. We have e squared, so I'm going to find the e button, or e to the something button, square it, times 9, because there's multiply next. We get 66. X is equal to 66.5015. Okay, we're going in our directions. It says round to the nearest 10,000, so we're going to go to the 10,000s place. So we have tenths, hundreds, thousands, 10,000s. So we're looking to the number to the right. It's a 0, so we're going to keep this 5 the same. So 66.5015. That's your answer. Okay. So what did I do again? First thing I did is I noticed it's solve. I have 3 terms. I condensed the two natural logs into natural log of x over 9 is equal to 2. Then I realized natural log is just like saying common log base e, right? I'm sorry, log base e, not common log. Then I rewrote this equation as e squared is equal to x over 9, multiply both sides by 9, simplified x is equal to 9 times e squared. And I use PEMDAS on my calculator for orders of operations. We know that there aren't any parentheses, but exponents are next, so I typed into my calculator e squared first, and I took the answer to multiply by 9. Okay, you do not want to write 9 times e and then square that. Okay, that would be wrong. Does that make sense? Okay, and that's your answer. Watch me do number 2. Spell. So we got natural log of x minus 9 minus natural log of 4 is equal to 5. So we're going to take natural log. We have two natural logs. We're going to condense them. X minus 9 over 4 is equal to 5. Okay? Then it's going to be e to the 5th is equal to x minus 9 over 4. Then I need to solve for x, so I'm going to multiply both sides by 4. So it's going to be 4 times e to the 5th is equal to x minus 9. Then we're going to add 9 to both sides. We've got 4 times e to the 5th plus 9 is equal to x. Okay? So now I have my calculator ready as one fell swoop. I have to use PEMDAS when I'm putting this into my calculator. Okay? So I'm clearing out my old calculation. So, first thing I want to do is ask myself, are there any parentheses? No. Any exponents? Yeah, e to the 5th. So there's actually an e to the exponent here on this type of calculator. So I'm going to put 5 as my exponent first and then type that e to the 5th button, or e to the x button. I get this number, I don't care what it is. But I'm going to multiply by 4. Okay, press equals. I get another number, and then I'm going to add 9 to that, plus 9. We get 602. X is equal to 602.65263. Going to the 10,000s place, we got tens, hundreds, thousands, 10,000s looking here. The number here is a 3, so we're going to maintain the 6. Round it down, 602.6526. Okay, and that's your answer. Okay, so sometimes you have large numbers, sometimes you have small numbers, but these are the answers you have. Okay, that's it. Any questions on numbers 1 or 2? All right, so why don't we take time, discuss this first. 1 still 2 is about number 1, 2 still 1 is about number 2. Okay, number 3, let's do this one together. Please write this down. Natural log of x minus natural log of 4 is equal to 1. Okay. Okay, so I'm noticing there's 3 terms. So what do I need to do with these first 2 terms? Condense. Good, thank you for using the right terminology. So we're going to condense here. Got natural log of x divided by 4, right? Because there's that minus sign. All equal to 1. What base are we assuming with a natural log? E. Base e. So what should I write next? How do I convert this to an exponential equation? So, what should I start with? What's the base here of the natural log? E. So we're going to start with e to the first equals x over 4, right? Okay, e to the first is like saying e, right? And we have an x. What's happening to the x on the right side? What's it? It's being divided by? What's the opposite of divided by 4? Multiply. So we're going to multiply both sides by 4. So we got 4 times e to the first, which is 4e is equal to x. Okay. Now we're going to go to our calculator and type that in. So some of you have that graphing calculator, so you just put it in as one fell swoop. One equation, press equals on for the rest of you that might have a scientific. So you have to deal with e. What's the power of e over here? 1. So you have to literally put e to the first on this example. So you're going to go find the e button. Well, there's an e button anyway. So we're going to do 4 times e, and then you get your equal sign. You get 10.8731. So x is equal to 10.8731. 2. Looking at tens, hundreds, thousands, 10,000s. So we got 10.8731. Some people don't have an e button on their calculator, like e to the first. So you have to put e to the first for it. Other people do. Every calculator is different, so if you need help, let me know. I'll come and help you out. So. All right. Number 4. Let's have you do this one. Start this one off. Well, actually, we'll start this one off together. Okay. There's 3 natural logs, so what do I need to do to... what can I do? Condense which 2? The first 2, right? So I could condense natural log of x times 2, right? Because there's a plus sign there. Is equal to 70. Oh, natural log of 70, I'm sorry. Okay. I have a natural log equal to a natural log. What happens? They cancel out. They disappear. So we have x times 2 is 2x, which is equal to 70. Okay. What do I need to do now?
Divide by 2.
Good. So x is equal to...
The logs just cancel out.
Yep. The natural logs just cancel out, right? Because this is 2 logs with the same base of e, right? Remember that? That's your answer. So it could be as easy as that, or you could have harder ones. The next one will be pretty hard.
Is it, can you cancel them out because they're on the opposite side of the equal sign?
Yeah. We learned that the last unit, or in the last test. So when you have a log with the same base equal to another log of the same base, then you could cancel out the logs and just make whatever's after them equal to each other. So we have a natural log equal to a natural log. They have the same base of e, so we could assume that we could get rid of them. Okay. Next one. Oh, my hand's sticky. Number 5. Let's have you do this one by yourself. Ready, set, go. Okay, so this is like the previous problem. So we still have to condense. We have a natural log minus another natural log is equal to 4. So just got natural log of 2 divided by natural log of negative x. Oh, I'm sorry. Why did I write x? Sorry. 2 over negative x, right? Is equal to 4. If you get a little confused with all the negative signs, all you have to do is just put parentheses around the natural log, or what's after the natural log. Kind of helps me out when I do it, okay? Then I have the natural log is already isolated, so it's going to be e to the 4th is equal to 2 over negative x. Okay. Now this one's a little different than before. Usually x is in the numerator, but this time x is being divided, right? So we want to isolate the x. So really x should never be in the denominator, so I have to multiply both sides by negative x. And while I'm at it, I could bring e to the 4th back down over here because I need to isolate the x anyway. So watch what I'm going to do right now. I'm going to skip a line and see if you guys get what's going on. Negative x is equal to 2 over e to the 4th. Raise your hand if you're confused with what I just did. Okay, so in order to get negative x away from the denominator, I have to multiply both sides by negative x. So we get negative x times e to the 4th is equal to 2, right? You got that part? How do I get negative x isolated? I have to divide both sides by e to the 4th, right? When I do that, e to the 4th comes down here. Okay? I just skipped a step earlier because I'm used to that. So once you see you could skip steps, you could do that. Okay, and we don't like a negative x, so we have to multiply everything or divide everything by a negative sign. So we have x is equal to negative 2 over e to the 4th. Okay? So now I'm going to go put this into my calculator. So I'm going to have a little bit of an issue when I put this one in because I have e to the 4th in my denominator. So I have to tell my calculator to save that. So here's a new method. Some of you have scientific calculators. Or any calculator, you have a memorization or a memory function on your calculator. So I want to memorize e to the 4th on my calculator because I'm going to predict I'm going to need that. So I'm going to put 4... the e to the button, then it gives me a number. Okay, that's e to the fourth right here. I want the calculator to memorize that number for me. So I'm going to put m plus, I'm going to say, add that to your memory, please. And it just added it, okay? And I'm noticing that the MR, or memory recall button, is outlined now, because it's telling me it's saved. So now I'm going to clear everything out. But my memory recall button is still outlined, so it's showing that there's something in memory. I'm going to take -2. So I'm going to type 2, press the negative button, and I'm going to divide by what I just saved. So divide by the memory, or what's in my memory. So I'm going to go, I just pressed divided by, I'm going to press the MR button, and what that does is just recalled what I just saved, and I'm going to press equal, and I get my number. Okay, so it's going to be negative 0.0366 Okay, looking to the 10,000ths place. It's a 1, so it's going to be negative 0.0366 is your answer. Okay, that's what your x is equal to. That's how you do this problem, okay? So this one's a little bit more advanced, a little bit more difficult. Alright? Now, I will say that all the calculators are different, so if you need help on any particular calculator, please ask me how to do it, okay? That way you know how to do it. And whatever calculator you use, you stick to it. I will say again that graphing calculators, with the ones with the big, like the TI-82s to TI-89s, these kinds are like real nice because you can put the whole equation down before you actually calculate, and then you can check before you press enter. It's really convenient, I will say, because when you go up to like harder math and you have this long calculation, it's all like, oh, I can just put it all in and it does it for you. It does PEMDAS for you. Okay? Whereas if you're using a smaller calculator like a scientific, you got to be really sure you're careful all the way through. And you might do a long calculation, you might mess up right at the very end, you have to start over. It's very frustrating. Okay, last one. Raise your hand if you want me to help you out with this one. You want to try this one on your own. Raise your hand if you want me to help you. Okay, go by yourself. Try this out. Okay, so natural log of x plus 6 minus natural log of x is equal to 71. First thing I do is condense. We got natural log x plus 6 over x is equal to 71. Oh, no, sorry, natural log 71. That's the first step. Okay, we have two natural logs equal to each other. Bases are the same. What can I do? Erase the bases, right? Right? X plus 6 over x. Let's look at this carefully. X divided by x is 1. There's two terms here. 6 divided by x is 6 over x. Okay? Follow me so far? Now we're going to subtract 1 from both sides, so we got 6 over x is equal to 70. Multiply both sides by x. 6 is equal to 70x. Divide both sides by 70. X is equal to 70, or 6 over 70. And we can simplify that. 3 over 35. So this is an answer. You could also just go to your calculator now and just put 3 divided by 35. Is 0.08. 571, and then there's a 7 there. Look to the right, it's a 1, so just leave the 7 there. That's it. So there's a variety of answers. Some of them are harder, some of them are easier. Variety of problems. So you got to really practice the skill on your calculator. You do get a calculator on your test, but you need to know how to use it. Okay, that concludes this lesson.